Hello everyone, a very warm welcome to you all. Today in this video, we're looking at deploying and verifying your smart contract, in this case an advanced storage contract to Kairos testnet, which is Kaia testnet basically. So having said that, let's head over to Remix to test out our contracts. We'll go over the contract, then we'll go over deploying a contract and also verifying those contracts. Alright, so okay, so this is our advanced storage contract. So just like we did in the previous simple storage contract, this has a little bit of addition where we added some kind of functionalities and pretty much it. Let's go over the contract. So the first thing here is we have a vault manager, right? Address basically. Then we also have a custom error. So custom error is a way to also like handle errors in Solidity basically. Then we also declared a constructor. So if you don't know, a constructor is a function that runs when a contract is initialized, basically. And in this constructor, we basically just assigned msg.sender, which is a global variable, to the vault manager declared up here. So also we have the struct of investment vaults containing different components, the investment duration, return on investment, if it has been initialized or not, and the identity card. Moving forward, we declared a variable with the investment vault struct type, and we called it investment vault. So also we initialized a function that modifies the investment vault. It basically checks if the person who calls this function is not the vault manager, it reverts with the custom error declared above, right? And it basically just sets other components such as investment duration. We use the timestamp and also the days unit. Also, we use the new keyword to create a new instance of this contract declared down here. So this contract is basically the customer identity card in this case, which also takes an address at deployment, right? And we passed in the vault owner. And also lastly, we use the key value mapping method to initialize our struct. As you can see, we have the key value, pretty much it. And we also have this read function, right? Return or retrieve investment vaults, retrieve customer information. And we also have this write function, which basically edits the return on investment, right? Pretty much what our contract does. So let's go over to deploying our contract. Now, the first thing you want to do is to compile your contract. So as we have previously said, DPM understands bytecode, and to do this, we have to compile our contract, which is high level language, into bytecode. And to do that, we use the Solidity compiler, basically. In this case, we are using compiler 0.8.826. This has been set to auto compile. You can just tick this box, so you don't have to always manually compile. Right, pretty much it what we want to do here. Alright, so having compiled our contract, the next thing we want to do is to deploy our contract. So we have to head over to the deploy and run transaction tabs. As we can see in the environment section, we have Remix VM, right? So this is like a local instance of the VM to quickly just test things out. But in this case, we want to quickly deploy to Kairos testnet, which is Kaia testnet. So for that purpose, we have to change our environment to injected provider. This basically gives us the functionality to load up our wallet to Remix, so we can sign transactions basically. Now, as you can see, we have our account loaded up with this testnet fund. Mind you, you don't have MetaMask installed, please do install MetaMask. So to be able to sign transactions and execute transactions, you need to have enough testnet funds. These are not actual real funds, but they are just for test purposes. So if you do not have test clear, you can head over to your file sets and just follow this process. Paste in your address and run the file set. Alright, so in my case, I'll be skipping this step because I have enough testnet funds. Moving forward, we want to deploy the contract. As you can see, the contract is loaded up, and all you have to do is just to click the deploy button. And now, as you can see, this transaction is pending. So we'll wait for it to load up MetaMask. So yeah, let's confirm this transaction and wait for it to be added to the blockchain, right? So as you can see, the transaction was successful. We have our contract deployed. So let's check this on the Block Explorer. So Block Explorer basically helps us to get the information about the block, about transaction, about contracts, or even about an account. So this is the transaction hash, and as you can see, we have the block in which the transaction was included. We have the created contract, we have the time, we have the gas used, the nouns, and pretty much it. So if we check the internal transactions, basically, you're going to see that this type of transaction actually created a new contract. Okay, so let's head back to Remix. So now that our transaction was successful, we successfully deployed our contract to the testnet, in this case, Kairos testnet. Congratulations. So now the next thing we want to do is to interact with our smart contract. As you can see here, we have three read-only functions and two write functions. Also, how do I know that? So Remix kind of like tagged them with different colors. So it tagged the read-only function with blue and the write-only function with a color like orange, right? So if this were to be a payable function, it would be tagged a red color. Right, so having said that, let's take a look at some of the things in our contract. So we have Vault Manager, which equals to this address. And if we check our contract, while deploying, we said that Vault Manager should equals msd.sender. Right, and at the time of deployment, our msd.sender was this account. And that was why I did set the Vault Manager to be the account. I hope that makes sense. Also, let's try to retrieve the investment vault. At the moment, it will still return the default values for each of these struct items because we have not modified the state yet. So to modify the state, we have to basically input the details and just initialize the transaction. So for this one, I put 20 days. Let's set this to 100. And basically, let's copy this address and paste as the vault owner. So let's click on transact. So yeah, I'm basically waiting for the transaction to go through, and let's hit the confirm button. Pretty much it. So once this is done, you're gonna see some state updates, and once we try to click this, it updated the state to this information that we did set here. Alright, so that's pretty much everything you need to know about deploying your smart contracts to the testnet and also interacting with your smart contract. Alright, so moving forward, we want to also do something really cool, which is of course verifying our smart contracts. Okay, so usually the deployer of the contract is only the one who has access to the contract source code, but it also makes sense for the public to have access to your contract source code. And to do this, you need to verify your contract. So let's take a look at verifying contract in the following steps. Now, to verify our contract, we'll be using Clayton Finder Block Explorer UI. Alright, so you have to navigate to this part, and pretty much it. Let's quickly connect our wallet, MetaMask, and yeah. So I connected the deployer address account to Clayton Finder. Okay, so let's head over back to Remix, and I quickly want to explain one or two things. As you can see, this contract doesn't have any imports, basically. But in the case where writing a contract that has multiple imports, right, you would want to compile or flatten all of the code into a single source code such that you can tell the verifier task even at the block explorer that this is the old code that you used for your contract. And to do that, you have to be able to flatten your code into one single file. Right? You just have to head over here and click on the file and just flatten basically. So when you flatten your contract, it basically gives you a single source code that you can upload on the Block Explorer UI. But in this case, this doesn't have multiple imports. As a matter of fact, it's just a single contract. So we are going to be using this in our Block Explorer. So let's go over this one step at a time. Now, is this contract for a token? This is not a contract for a token. Let's basically just paste the contract address and copy that. This is the contract address. Now, source code solidity file, right? Now let me upload the file. I already downloaded the advanced storage contract, right? And pretty much it's the compiler version. So while I was deploying, I need to check the compiler version that I used. So in this case, I used 0.8.26, right? I have to select compiler version, open source license type. I think it should be MIT, right? And MIT EVM, I think it's default. If I had set the optimization to true while I was compiling, I would also set this to true and put the default value, right? So there are no constructor arguments in this case, so we don't have to bother about encoding them. And so let's just sign transaction and basically wait for this to be verified, right? So back to main. Now let's copy our contract address and fingers crossed we should be able to view the contract code. Oh yeah, pretty much it. We've been able to verify our contract source code, and now it's available in the block explorer. It's available to the public. They can basically also perform transactions, read and write the contract. So pretty much it. I hope that you have been able to learn one or two things watching this video. So that'll be all in this video. See you in the next video.